Hey guys, so today's lesson is 4.4 on patterning in relationships, and it's solving problems by examining simpler problems. So basically what we're doing is we're taking something that's seemingly very difficult, so a big problem, and we're breaking it down into little problems, therefore having the tools and step by step to solve the bigger problem. So first I want you to think about a time where you had a big problem to solve, but before you were able to solve that big problem, you had to break things down and kind of solve all these little things first before you could solve the bigger picture, the bigger problem. Because by breaking things down into easier steps, rather than just doing something all at once, it's a lot easier to handle and it's a lot easier to manage. So I actually took the example from the textbook, and this is a pyramid of golf balls, and we have to try and figure out how many golf balls are in this particular pyramid. So I want you to look at the table of values here. And what the textbook has done is they've taken each layer, and I want you to think about each layer number, which is in this column here, and think about it as term numbers or figure numbers. Okay, so they take the first layer number, and there is one golf ball there. So another way to represent the one golf ball, they've broken it down into powers and exponents. So 1 to the power of 2 is literally 1 times 1, and 1 times 1 is 1. And number of golf balls in the first row is 1. If you look at the second layer number here, if we follow that same particular pattern, 1 to the power of 2, it's not, for the video, the picture that came out on the video here, it's not 100% clear. But if you look here and you see the 2 golf balls, there's actually 2 more beside those 2, underneath that first golf ball. There's actually 4 there. So if we represent that as 2 to the power of 2, then that would give us 4. And there are 4 golf balls in that second layer. So the pattern so far to find out the total number of golf balls is 1 plus 4, because we're taking the 1 from the first layer and we're taking the 4 from the second layer, and therefore giving us the total number of golf balls as 5. If we keep up with that same pattern for layer number 3, so layer number 3 is right here. I just put little dots on them. That's a layer, but beside those 3 golf balls, there are 3 other ones, and behind those are 3 other ones. So we could represent that as 3 to the power of 2, and that is 9. So our pattern would be 1 plus 4 plus 9, because again, there's 1 in the first layer, there's 4 in the second layer, there's 9 in the third layer, giving us a total of 14. If we keep on with that same pattern, then for layer number 4, which I'm just doing on the top right here, I want you to think for a second what the number of golf balls in each layer would be. And if it's 1 to the power of 2 for layer 1, and 2 to the power of 2 for layer 2, and 3 to the power of 2 for layer 3, then we can assume that it would be 4 to the power of 4 for layer 4, giving us a pattern of 1 plus 4 plus 9 plus, and 4 to the power of 2 would be 4 times 4, which is 16. And if we add 1 plus 4 plus 9 plus 16, that would give us 30. So our total for layer number 4 is 30. And we could continue in this same fashion for layer number 5, layer number 6, layer number 7, and layer number 8. And what we would do is for layer number 5, it would be 5 to the power of 2, layer 6, 6 to the power of 2, layer 7, 7 to the power of 2, and layer 8, 8 to the power of 2. And you would get all of those totals, right? And then you would add all of those totals up. So for your last layer, it should read 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64, because 64 would be the last row, 8 to the power of 2. So if you add all of those things up, then you would find that you'd have 204 golf balls in that entire pyramid. So again, if somebody just asked you right away how many golf balls in that pyramid, it'd be very difficult to look at this picture and be able to count them. But by systematically going step by step and doing layer by layer and then adding those up, then we can solve that bigger problem. Okay, so this was a short video by me, and for this one there is not a key assessment question. What I would like you to do is I'm posting another video of another teacher giving another example of solving problems by examining simpler problems. So there will not be a key assessment for me, but please watch the other video, and it will do a further demonstration of another kind of similar problem. Okay, see you guys tomorrow.